Oh, I remember Sonic the Hedgehog. I was only a 15-year-old lad playing video games on my Sega Genesis, and Sonic was the fastest. It was a blur. He would start off with his little red shoes running a little bit, and then before you know it, he was this streak of blue light soaring through the air and going around giant loops, and oh my gosh, best game ever. Loved it so much. Anyway, we're going to be talking about acceleration today, and we're going to be looking at some new formulas about how to calculate what happens when your speed changes, because your speed doesn't always stay the same. It can go slow and then fast, or fast and then slow, and we're going to be looking at that today. Imagine you have a car. The driver has his foot on the brake as he's waiting for the red light to change. The car is not moving, it's still. So we could say his speed, right, or his velocity is 0. Right? His speed or velocity is 0. And we could write that by saying his speed would be v, right? And it's going to be 0. But you know he's going to start moving pretty soon, right? As soon as that turns green, he's going to start moving. And so the light turns green. As soon as the light turns green, the driver is going to put his foot on the accelerator and he's going to begin to move. And we can see this motion. Right? The car starts to move ahead further and further and further, faster and faster. He has a new speed now. Let's say 10 meters per second. This is confusing. We now have two different speeds. There needs to be a way that we can differentiate between these two speeds. His 0 meters per second over here, this was his starting speed, his initial speed, what he started as. So we're going to change this variable. We're going to give it a little symbol. We're going to say it's not just v, it's vi. I meaning initial, his starting speed. That's an N. This new guy over here, this new V over here, we're going to call him VF. VF meaning the final speed, what he's doing at the end here. So we see a car at a red light with no speed, and then when the light turns green, it goes to 10 meters per second. All of this, going from 0 to 10 meters per second, took a period of time. And we could say that time was, we can make it anything we want. Let's say it was 2 seconds. It took 2 seconds for him to go from 0 to 10 meters per second. Like we were saying, your speed isn't always the same. It can change. The amount your speed changes in a certain period of time, that's your acceleration. How much your velocity or speed changes in a certain period of time is acceleration. And that, I'm going to show you the equation for that today. We want to find our acceleration. Acceleration is how much your speed or your velocity has changed in a period of time. So the first thing we have to figure out is how much has our speed changed? Well, let's look at our speeds. We started at 0 meters per second. We went to 10 meters per second. How much has the speed changed? It changed by 10 meters per second. Well, what if my speed had been 5 meters per second to start with? If the car was going 5 meters per second and now it's going 10 meters per second, how much did it change then? And you would say it only changed 5 meters per second. And the formula you just did in your head is actually this. Your final velocity, which in this case happened to be 10 meters per second, minus your starting velocity, which in this case was 0 meters per second. And that equals 10 meters per second. Or in the second example, it was 10 meters per second minus 5 meters per second, which works out to be 5 meters per second. You do this in your head all the time. You can figure out the different speeds of things by subtracting the final speed that something is going by its starting or initial speed. This is the change in speed, Vf minus Vi. And remember, we use the symbol delta to represent change. So what you actually found is what's called delta V. Vf minus Vi is our delta V, how much our speed has changed. We're going to use this in the final equation here to find acceleration. So let's go down to that. We need delta V. How much has your speed changed? And we need to calculate the time in which it changed. In our case, it was 2 seconds. So the equation actually is delta V divided by T equals A. Now, sometimes delta V is a little confusing, so we can actually just write the whole thing in here. Vf minus Vi, the final speed minus the initial speed divided by time equals acceleration. And we'll do that together. All right, we have our equation for acceleration. The change in your speed divided by time, delta V over T, or if you prefer kind of the more blown out exploded version, Vf minus Vi over T. All we do is include our numbers in the equation. Vf is 10. Okay, so we're going to put that in. Vf is 10 meters per second. And we're going to subtract that from Vi. Vi was 0 meters per second. So there is our change in speed. Our time was 2 seconds. So we put 2 seconds down here. And the equation works out to be 10 meters per second. Oh dear, I'm going to run out of room. Let's make a little more space here. 10 meters per second divided by 2 seconds. Well, what are we left with? This would be 5. 5. Now, interestingly enough, this is a unit, and so is this. They can't cancel out. So what we get is 5 meters per second squared. This is the unit for acceleration. Our car was accelerating at 5 meters per second squared, which means every second it was driving, it went an additional 5 meters per second faster. So we could even figure out how fast in 3 seconds would he be going. If the time was 3 seconds, how fast would he be going? Well, it would simply be every second he goes 5 meters per second. So second number 1, he was going 5 meters per second. Second number 2, 10 meters per second. Second number 3, 15 meters per second, and so on and so forth. So this is the acceleration of the car, 5 meters per second squared. We'll do one more problem for practice. All right, let's do our practice problem. Billy's riding his bike and has to come to a stop along the road. So let us give ourselves some information. Billy's riding along the road. His speed, let's start. His starting speed was, say, 15 meters per second. Now, this is his starting speed, so it's not just V. It's going to be what we call VI. Now, as Billy is riding along, he comes to a stop. Complete stop. This is his final speed. This is going to be 0 meters per second, and we call it VF because it's his final speed. It takes Billy to go from 15 meters per second to 0 meters per second. It takes him some time to do this. Let's say the time it took him to do this was 3 seconds. It took him 3 seconds to come to a stop. No big deal. Okay? Hey, you know what? Let's make that a little bigger. Let's make it 5 seconds. It took him 5 seconds to come to a stop. We want to figure out what is his acceleration. Acceleration isn't just speeding up. It's also slowing down. Acceleration is your change in speed over a period of time. So we have to figure out what is this change in speed. And remember, change in speed is what we call delta V, the change in your speed. And we can figure this out by using the formula VF minus VI. This will tell us how much his speed has changed. Well, his VF is 0 meters per second, so we have to write that in there. Okay, VF is, for him, 0 meters per second, all right? And we subtract VF from VI. So the VF, the final speed, is subtracted from his starting speed. So it's going to be 0 meters per second minus 15 meters per second. This is the equation we have so far. Now, his final speed here subtracted from his initial speed. 0 minus 15. Now, a lot of you want to say 15 meters per second, but that's not true. You have to follow the math. 0 minus 15 turns out to be negative 15 meters per second. This is his delta V. This is how much his speed has changed. Now, we simply need to put that into the equation, and the equation which we wrote down earlier was delta V divided by t equals acceleration, and now we just need his time, and we said the time earlier was 5 seconds. So, his delta V we write down as negative 15 meters per second divided by 5 seconds. And what's 15 divided by 5? 3. But it's not just 3. It's negative 3 meters per second squared. And this is the interesting thing about acceleration. Negatives matter. When you have positive acceleration, you're speeding up. But when you have negative acceleration, you're slowing down. Positive acceleration, you're speeding up, but negative acceleration, you're slowing down. And that's going to be really important. Your negative numbers are really going to matter here. So that's our second example here for acceleration. We'll do some practice problems, and we'll see how you do, but don't worry. We're going to work on this in the next couple days, just like we did speed. And you might be asking, some of you guys might be asking, is there a triangle for this? Is there a triangle like there was a triangle for speed? What kind of triangle would it be? And you can bet your bottom dollar there is absolutely a triangle. Maybe you want to try to figure out what would go inside each of these spots. We're going to talk about that tomorrow, but maybe you can get a little jump on it already and see if you can figure out what goes in there. All right, we'll see you tomorrow.